Okay, this problem is for the coefficient assignment, question number 2. So you obviously start off with looking at your real life situation. It says we have a 2 kilogram box on an incline plane angled at 22 degrees. Okay. And then we always draw a free body diagram. Normal force perpendicular to your surface, force of gravity, straight down. If it is going down the ramp, then you have a friction that goes up the ramp. And then we write our coordinate system. Remember, for these kinds of problems, we are tilting our coordinate system. So we have a coordinate that goes up and down, into and out of the inclined plane. And then you have a coordinate system that goes like this. Okay. And then look at the forces that are not on your coordinate system. In this case, it's the force of gravity, and that one is one that we have to break into components. Remember, the angle of incline is always the angle between the force of gravity and your y-axis. So then we draw our little triangle. Remember that you draw a piece perpendicular and then a piece parallel. And then this is your opposite side. This is your opposite side. So that's going to be your hypotenuse times sine theta. And then this is hypotenuse times cosine theta. So then I'm going to write the sum of the forces, and for that you need to make sure that you are writing all of the forces in the y direction. So in that case, that would be this one and this one. Those two forces are in the y direction, and then you look at what forces are in the x direction. That would be this one and this one. And then for inclined plane problems, you do have to say which direction is positive. So it's just easier if you make the direction it is moving in positive. So if it's moving down the ramp, we're going to say that this is positive. So everything going in the opposite direction is going to be considered negative. So if I start writing the sum of the forces in the x direction, I have mg sine theta, and I have friction. And then the sum of the forces is always equal to mass times acceleration. In this case, we're looking at the acceleration in the x direction, which is up and down the ramp. I think for this problem, it is accelerating, so we can set it equal to ma. And then for the y direction, we have the sum of the forces in the y direction. In this case, that would be the normal force goes up, and the force of gravity component goes down. And then it's actually not accelerating in this direction, so we can set this equal to 0. Okay, and then and that's all before we started looking at what the problem's actually asking you to solve for. So for part A, it asks you to solve for the normal force. Well, the normal force is right here, so I just want to basically get it by itself. Plug in your numbers. And calculate. Make sure that your calculator is in degrees. So in this case, I should get 18.2 or something very close to that. And that's newtons. And this is your normal force. And then for part B, it asks for the acceleration down the slope. So obviously it's accelerating now, and so we want to look for A. But if you notice, in the problem, it never told me what F was. What it did tell me, though, is that the coefficient of friction was given as 0.11. So if I know my coefficient and I know my normal force, then I can use that information to solve for my frictional force. And then that friction is this friction here. So kind of putting all that together, I'm going to do it all in one step. So I'm going to say mg sine theta minus, and then I'm putting in this. You can do it in multiple steps, but I'm going to just do it all at once. I'm going to put this wherever I see this. So for friction, I do mu k times normal force equals ma. And then again, the goal was to solve for acceleration. So I'm just going to divide by m. And then I can go and plug in my numbers. So mg, let's see, m was 2. Gravity is 9.8. Sine of 22 minus coefficient, which was 0.11. Normal force, which was the number I got earlier. All divided by the mass. I got 2.67, which rounds to 2.7 meters per second squared. Okay, well, hopefully you found this video helpful. Let me know if you have any more questions, and I'll see you in class.